We're going to continue on now with section 1.2, but now we're going to get x's in the bottom. So this is stuff we got to worry about. So to start off, I have another little aside here. If you'll remember, hopefully, got something like this. Y equals 1 over x. So when is this bad? What x makes this really, really bad? Think about it. If x is 0, then y becomes 1 over 0, right? Remember we called that undefined. This is bad, in case you don't remember. This is bad. You can't divide by 0. If I have a bunch of people and I want to divide them into 0 groups, the only way I can do it is by, I don't know, lighting them on fire or something. So you never, ever, ever want to divide by 0. Write that somewhere. I'll write it down here. We never, ever, ever want to divide by 0. So we're going to be real careful. If you ever see something like this, the very, very first thing you need to write next to it is, hey, x can't be 0. Same thing for here. If we had something like y equals 1 over x minus 3, we might say, well, when is this on the bottom going to be 0? Say, well, if x equals 3, then y is equal to 3 minus 3, or 0, which is also undefined. Again, this is bad. So we don't want to divide by 0, so for this problem, we might say, well, x can't equal 3. Because again, we never, ever, ever want to divide by 0. So we're going to keep this into consideration whenever we start to solve the rest of these kinds of problems. Okay, so make sure you got this. Draw little stars, no happy faces. I'm a big flower person. Draw little flowers around it. We never, ever want to divide by 0. And that's not just for this. This is for pretty much anything in algebra. All right, let's look at this example. Try 1 over x equals 1 over 5 plus 3 over 2x. Now this is pretty much like what we had before. However, now we have to deal with this fact that we never, ever, ever want to divide anything by 0. So we want to start, we're going to do basically the same problem, but we're going to add 2 steps. We are going to figure out any constraints on the problem. And by constraints, I mean we want to figure out any x not equal 2's. We'll do that at the beginning. And at the end, we're going to check our answer against our x equals thing, x not equal to. All right, so we're going to add 2 steps only when you get x's on the bottom. Okay, only when you have the x's on the bottom for these things do we need to worry about this. So all the problems that we just did in the previous section, the previous subsection 1.2, we didn't need to worry about it. But here we do. So we want to go back now and look at our example and say, well, when is this bottom part, when is this 0? What makes x 0? This is a little hard because the question is pretty straightforward and it's almost too easy and you're like, is that the right answer? Is that what I mean? Yes, that's what I mean. X cannot be 0. Because if x is 0, then I'm going to be dividing by 0. Okay. When is this 0? Well, 5 is 5. No matter what x is, that's never going to be 0. That's a number. It's just like the previous problems that we were looking at where we didn't have variables on the bottom, so this is just fine. This is going to be no problem whatsoever. And then come over here. Well, when is this going to be 0? X equals, again, when x is equal to 0, that's going to be on the bottom. So we have to explicitly say x cannot equal 0. So now when we're working this problem, we really want to figure out any constraints, and we're going to put them all together and say x cannot equal 0. We're going to put this somewhere. We're going to put like little smiley faces on it and flowers and exclamation points, and you know, that's supposed to be a, I don't know, firework? Whatever it is, kind of looks like a angry caterpillar. Anyway, so you want to do whatever it takes, basically, to remember the fact that you're going to have to come back to this later, because we have this step here at the end. And the problem is, you'll remember to do it in the beginning, hopefully, but by the time you get to the end, you're going to be so excited that you actually solved the problem, you're going to forget to do this last step. All right, so we now know that x is not equal to 0. We don't know what we're going to do with it yet, but we know it's eventually going to be important. 3 over 2x. Okay, now we want to find the LCD. The LCD is pretty much going to be the exact same thing it was previously, except now we also have to deal with the fact that we have x's. So again, the LCD is going to be, we're going to multiply the whole thing by the LCD. So when we do that, we want to make sure that whatever's on the bottom goes away. The LCD in this case is going to be 10x. So it's the 10 to take care of this 5 and this 2, and it's the x to take care of this x and this x. So you can kind of check it in your brain before you get too far. You think, well, if I multiply 10x by this first term, well, the x is going to go away because there's one on the top and bottom. If I multiply 10x by this term, the 5 is going to go away. If I multiply 10x by this term, 2x is going to go away and be left with 5. So if you can think that far ahead, go for it. If you can't, just guess and hope you got it right. If not, it'll be really, really obvious because something won't cancel out. So there's really not a way to screw this up unless you just mess up the algebra, just mess up the math. But the new stuff that we're learning, it's actually pretty forgiving. I'll multiply both sides by 10x. So I've got 10x times 1 over x equals 10x times 1/5 plus 10x times 3 over 2x. All right. So this first term, the x's cancel out. The second term here, what cancels out? Cross out the 5 down here, we're left with a 2. Now circle this x or do something to it, because I guarantee when you get excited and we copy the next line, you're going to forget that x is there, especially if you write small. All right, now this next one, we got 10x over 2x, so the x's cancel. And 10 over 2 is 5. All right, so we're in good shape. Now, this is, again, the next step that we never, ever, ever want to skip. 10 times, and who's left on here? In this first term we've got left is a 1. We've got 2x, here we get the x, and the guy who's left here is just the 1. And then we have 5, and the guy we have left in our parentheses is 3. So I've got 10 equals 2x plus 15. Now, isn't that wonderful? Like, compared to what you started out with, isn't that just, like, gorgeous? Like, deserves a, I don't know, a trophy for being, like, prettiest equation. Except I can't spell because I'm so excited. Prettiest equation. Alright, whatever. I digress. Now we want to move, as always, all the x's to one side and all the numbers to the other side. So it's pretty straightforward. I just need to move the 15 over and I'll be in good shape. So I've got negative 5 equals 2x. Divide both sides by 2, which I can do now. So I've got negative 5 halves equals x. And it's okay to do this. It's okay to get a fraction. Now remember that we can, got negative 5 halves equals x, so we can just rewrite that as x equals 5. Negative 5 over 2. Now, remember we drew this thing up here that had all these, like, caterpillars on it? Now we're on the last step. Even though you have an answer, wait. because at the very, very, very beginning, we said that x cannot be equal to 0. Okay, so when we get a solution like this, we need to say, is this okay? So we got x is equal to negative 5/2. Way over here, up here, we said x cannot equal to 0, right? Have we met that restriction? Yes. We're cool. We just said x can't be 0. We said not a problem. X is equal to negative 5/2. And this is actually okay. So this is a good solution. We can write this down and move on with life and be inordinately satisfied. Okay? So think about that. Does this make sense? Did the exact same thing we did before. We took an ugly problem. We just added this step here of putting an extra restriction on it. It's not really an extra restriction. It's necessary. Solved it all out. Look how nice this turned out. Isn't this gorgeous? And we worked it out and we got a very nice little happy answer. So everyone's pleased as punch. So let's work another one. Yay! I'm not celebrating. I'm sure everyone out there is celebrating extremely. All right. Try this one. X over x minus 3. 3 over x minus 3 plus 9. I'm really going to encourage you to go ahead and try to work this out on your own. See if it's making sense to you. Remember, we've got this special first step. Yeah, I'll write it over here. I'm going to say, what makes this 0? What makes that 0 on the bottom? So x cannot equal 3, right? Because if x equals 3, then that's going to be a 0. How about this guy over here? X, again, here can't be 3. But over here, there's no problem. Don't even have a fraction to worry about. Okay? So you want to do this analysis for each term in the equation. So now we're going to write our big fancy words. We say, well, x cannot equal 3. X cannot equal 3. Now we're watching Are You My Mother? Okay, so we're going to go ahead and write this out. X over x minus 3 equals 3 over x minus 3 plus 9. Just rewriting it so it's pretty. And I need to find my LCD. So here my LCD is just x minus 3. Okay, that's my LCD. So I'm going to multiply both sides of this equation by my LCD, x minus 3. Notice that I'm putting everything in parentheses now because I'm super paranoid and I don't want to mess something up. So I'm going to use lots and lots and lots of ridiculous quantities of parentheses. Okay. So I'm going to go ahead and work this out. I'm not going to cancel anything out until I have it written out, because if I do it the exact same way every time, I've got a much better chance of solving these problems right. So I've got x minus 3 times 3 over x minus 3 plus x minus 3 times 9. All right. Now make sure this makes sense. I have 3 terms. I still have those 3 terms, except in front of each one, I've now got that LCD, x times x minus, or of x minus 3. Okay. So think about what the next step is going to be. Are you my mother? All right. X minus 3 and x minus 3 are going to cancel out. X minus 3 here and x minus 3 are going to cancel out, which is actually pretty awesome. So I'm going to write my next step that I never, ever want to skip. I've got x, because that's the only guy that's left on this side, equals 3 plus, and then I've still got this x minus 3 times 9. Okay? So now I can keep simplifying. X equals 3, and I can distribute this guy throughout. So 3 plus 9x minus 27. Going to combine like terms, so 9x, 3 minus 27 gives me minus 24. All right. I am not your mother. I am a dog. Move all the numbers and x's to each side. That's what we're doing here. I'm going to eventually stop writing this, but I don't want you to forget yet. I don't ever want you to forget. I'm going to move my x's over to the left. So I've got negative 8x equals negative 24. And I get rid of the 8. Now I can divide, remember? Because I've got only x's on one side and only other numbers on the other side. Not that I can't do it before, but it makes life so much better when you do it in this order. Divide both sides by negative 8. And get 8x, x equals 3. Now we celebrate and leave, right? No, we say, is this okay? So is this okay? Is x equals 3 an okay solution? Is it? Suspense is killing me. Oh no! Look what happened. Sorry, somebody else get excited. This says x cannot be 3. We said that. We said we'll do this problem as long as x isn't equal to 3. And then what did it do? It made it equal to 3. Oh no, that's not going to work. No! So what we actually need to write here now is our answer is no solution. There's no solution to this because we said, all right, I'll play, but x can't be 3. We said, I want x to be 3 anyway. And finally, we just got to say, nope, sorry. Not going to play this game with you anymore. No solution. Okay? Make sense? Kind of like you say, we can watch TV, but we can't watch Are You My Mother? I say, I want to anyway. You don't give into equations. You can give into toddlers, but you can't get into equations. If you set the rules at the beginning of the day, say no x equal to 3. Down here, if it insists, you have to say, nope, sorry, no solution. Do whatever you can to make it make sense. Help yourself remember what's going on. But, I mean, it still kind of worked out nice when we got rid of those ugly fractions and we got a pretty, whatever that is, equation right there. Pretty equation. But in the end, we were bitterly disappointed. Poor equation. All right. New example. See if you can work this one out. Or at least get started. So pause it if you want. Try to get started on it. Otherwise, we'll just keep moving on. Remember my first step. Since I've got x's on the bottom, I have to do this. To say, when is this 0? So when is this guy 0? Well, you can say, well, x plus 6 is 0 when x equals negative 6, right? So I say, well, can't do that. And when is this one 0? Well, to be formal, you can say x minus 2 is 0 when x equals 2. So, nope, x can't be 2 either. Oops, x equals minus 6. Thank you. Then over here, when is this 0? This one might be a little harder to get started with. So go ahead and write it out. We want to know, when is this going to be 0? Hopefully, one of your first instincts is going to be to factor this out. Okay? Remember, this is x squared at the front. Since it doesn't have any coefficients on it, I can go ahead and set myself up. Now you want to think, what's a number or two numbers that have a product of 12 and a difference of 4? Product of 12 and difference of 4. Hopefully you get 6 and 2, right? 6 and 2. And since this is a plus 4, we want this to be a plus 6 and a minus 2. So remember, we kind of break these out. So we say, okay, well, either x plus 6 is 0 or x minus 2 is 0. So we'll say x is negative 6 or x is 2. But remember, we don't want it when it actually is 0. We want it when it's not. So we say, well, we're okay here as long as x is not equal to negative 6 or 2. Now this is kind of nice because we got a negative 6 and a 2 here, and we got a negative 6 and a 2 here. So we can actually just write one big fancy thing. X is not equal to negative 6 or 2. So we keep this somewhere for later and save it. Now if you want, you can like go down here wherever you think you're going to find the problem and say, hey, go make sure this answer is okay, in case you think you're going to forget. I have no idea if this is where we're going to end up, so that kind of gives you the idea. It'll be easier because you have real paper. My scrolly paper, it's harder. Okay? So, have we done a lot of work already? We haven't even really gotten started. Isn't that encouraging? All right. So we've got 3 over x plus 6. Just rewriting it because we need lots of room. I'm actually going to write this pretty small here in a second. X squared plus 4x minus 12. And I'm going to give you a hint. Whenever you have something like this, with the squared on the bottom and all this stuff going on, you want to write the denominators in factored form where you can. Okay, so write the denominators in factored form where you can. So let's rewrite this. Right, 3 over x plus 6 plus 1 over x minus 2 equals 4 over, now we already did this actually. We already factored this out. We factored it out up here. So this factors to x plus 6 times x minus 2. Okay. So now we've got a couple of options. Well, not really a couple of options. We've really only got one option. Now we need to find the LCD. So what's our LCD going to be? Remember, the LCD is something that when we multiply by each term, we want the bottom to go away. So our LCD here is actually going to be x plus 6 times x minus 2. It's actually going to be this whole thing. So this is going to be a big old problem to write out. And think about it, though. If I've got x plus 6 times x minus 2, if I multiply by this first term, the x plus 6 is going to go away. If I multiply by the second term, x minus 2 is going to go away. If I multiply by this last term, both of those are going to go away. All right, this actually works out quite nicely. Okay, so I'm going to multiply both sides by the entire LCD. And parentheses just keep getting more and more important as we go along. X plus 6, x minus 2. Now we're watching Go Dog Go, in case you were wondering. Alright, so multiply this whole thing over here, multiply the whole thing over there. Alright, you're going to have that same pattern. My LCD times the first term, and then my LCD times that whole second term, and then my LCD times that whole last term. Stop, dog, stop. All right. So now I can finally get some work done. Just going to make that a little bit more clear. So I got my LCD, my entire LCD in front of each one of those terms. So this x6 and this x plus 6 will cancel. This x minus 2 and x minus 2 will cancel. This x plus 6 and x plus 6 will cancel. And this x minus 2 and x minus 2 will cancel. So Now we got that really, really important step that we never want to skip. X minus 2 times 3, because that's all that's left here in that first term, plus x plus 6 times 1, because that's all that's left. And then who's left here on the left? All that's remaining is the 4. So I'll distribute my 3 through here. 3 times x is 3x minus 6. It's so silly. I mean, you might think, well, you know what, I can do this in my head. But honestly, it's one of those things where it's such an important step. And this is like the whole reason you're doing this, is to get this nice, beautiful equation that you actually don't have to mess around with. It's not supposed to be too traumatic. So give yourself the luxury, give yourself the benefit of being able to at least see it and see what's going on mathematically. And get excited about it. Be happy. And also, most of the time when I see students skip this stuff right here, this is when huge algebraic mistakes are made, which ruin the rest of the problem. Okay? So we got this. So again, I'm going to combine like terms. Oh, dog, go. 3x plus x is 4x. 6 minus 6 plus 6 is just going to cancel, and I've got the 4. So I got to actually kind of breeze through this. I've got all the x's on one side and all the other numbers on the other side, so I can now divide. Yay! So I'm going to divide by 4 and get x equals 1. Now, let's see how well I did. I did reasonably well. Let's pretend I did it up here. Now see, look how awesome I am. Look, it's right here. It says, hey, go make sure this is okay. Alright, so I have x plus 1, or x equals 1, I say, is this okay? So is it okay? So I said up here, x cannot be negative 6 or 2. Did I meet that criteria? Yep, I did. Because I said that x was 1. It's not negative 6, it's not 2, so I'm good to go. So I'm super duper happy. I've got a fantastic solution, and I'm ready to move on.